So for homework 1, we need to use the tooth growth data set. And so type in tooth growth, run, that's your data set. You also need to use library lattice because that's where part of your commands are going to come from. So to save time, effort, what have you, you want to attach tooth growth so that you don't need to use $signs and what have you. So then you can go histogram, len, run, and you can now export this to Word. So copy plot, export as PDF, whatever you want to do with it. Next, you go and you make a comparative histogram of the len variable by the sup variable, and you do that by histogram len tilde sup. Let's see if I did that right. Whoops. I did not do that. So it's tilde straight line sup. So this is your correct histogram. Export it, copy to clipboard. Don't forget that he also wants you to copy and paste your syntax, so this stuff, into your Word document as well. So then we can go on to make a box plot of your len variable. And then len tilde. Run. And so they're on the same scale, export, what have you. So you can go by so you can go mean of len, var for variance of len, and standard deviation of len. And then you can highlight all three, run it, and down here you can copy and paste. So then for F, you want to find the mean, variance, and standard deviation of the len variable by the variable sup. So basically you want to separate them into your two categories again. So you go by len sup sd by len sup bar by len sup mean. So, oops, run. So, copy, paste into Word, and you have your standard deviation and everything for F. So then, because we need to continue on, we need to detach tooth growth, run, and so now we no longer are using that tooth growth data. So for 2, we have the set variables, so x is greater than c or minus c 15, 13, 18, 14.5, 12, 11, 8.9, and 8. Run that. And so if you enter x, it should show your different values. So mean of x is 12.55. Median of x 12.5, and variation of x and that is 2. So for 3, it's kind of more of you need to read through the questions. So 15% fail due to 1 faulty light, 10% failed to 2, 5% to 3. So for A, what is the probability that a randomly selected car will have no faulty lights? It's 100% minus the 3 values. So just because I have my screen up, it's 100 minus 15 minus 10 minus 5, which equals 70. Because 15 plus 10 plus 5 equals 30, so 30 plus 70 equals 100. What is the probability that a randomly selected car will have at most 1 faulty light? So this includes 1 faulty light. So it's 70 plus 15%, and that equals 85%. And then what is the probability that a randomly selected car will fail inspection due to a faulty light? Well, that's 30%. So it just takes a little bit of reasoning out. And then for 4, a volunteer blood donor walks into the Red Cross blood donation center. What is the probability that she will be Asian and have type O blood? So for Asian and for O, it's 1.7%. What is the probability that a white donor will not have type A blood? So it's 100 will not have type A blood. So actually it's 36 plus 32.2 plus 8.8 plus 3.2 equals 80.2. So will not have type. It's 36 plus 8.8 plus 3.2. So it's 48 over 80.2, which is a 50 or a 60% chance that a white donor coming in not having type A blood. So what is the probability that an Asian donor will have either type A or type B blood? So add up all the Asians percent. So 1.7 plus 1.2 plus 1 plus 0.3 is 4.2, and that they'll have type A or type B is 0.8 plus 0.3. So 1.1 over 4.2 is a 26% chance. And what is the probability that a donor will have neither type A nor type B? Or type A nor type AB. Okay. So it's 3.2 plus 0.5 plus 0.3 plus 0.1. That's the AB. And then for A, that's 32.2 plus 2.9 plus 1.2 plus 0.8. And that, whoops, gotta run it, equals 41.2. So we need to do 100 minus 41.2, which is 58.8% chance that a donor not having type A or type B AB blood would come in. Pretty simple. Good luck. Hopefully this answered some of your questions. If not, I'll see you in class.